Hello, myself Shubhashish Shah, Assistant Professor of Mathematics of Greater Kolkata College of Engineering and Management, GIS Group. In this video, I will discuss about first order and first degree ODE non-exact ordinary differential equation. In the previous video, I have discussed about exact ODE and the solution procedure of exact ODE. Now, if a first order first degree ordinary differential equation is non-exact, then how to solve the non-exact ODE? I will discuss about it now. Now, we already know that the general form of a first order first degree ordinary differential equation is m dx plus n dy equal to 0. Now, what was the condition for exactness? The condition was del m del y equal to del m del x. If this holds, then we say that this equation is exact, and then we solve that equation following the corresponding rule for solving exact ODE. But if these two are not equal, if del m del y is not equal to del m del x, then we call that this equation is non-exact. Now, to solve a non-exact ODE, there is no direct procedure to solve a non-exact ODE. We have to first convert the non-exact ODE into an exact ODE, and then we solve that exact ODE following the procedure of solving exact ODE. So our main target will be to convert a non-exact ODE into an exact ODE. Okay. Now, what is the procedure of conversion of a non-exact ODE into an exact ODE? The rule is, if we multiply a non-exact ODE by a certain function, then that non-exact ODE is converted into exact ODE, and that certain function is called integrating factors. Okay. Actually, theoretically, if I tell you the theoretical thing, the thing is actually in exact ODE the given functions are integrable. So we will not have to convert that integrable function. That is, we can integrate directly since the given functions are integrable. But in non-exact ODE, the given functions are not integrable, so we have to convert the non-integrable functions into integrable form, and then we solve that following the procedure of solving exact ODE. So, to convert non-integrable functions into integrable functions, we need a certain function by multiplying which that ODE becomes exact ODE. Okay. So that certain function is called integrating factors. So I write the algorithm here. Non-exact ODE is multiplied by integrating factor, then it becomes exact ODE, and then solution. Okay. Now, how to find integrating factors? There are several rules for finding integrating factors. So here I will discuss about the rules for finding integrating factors one by one. Okay. So first rule number 1. Rule number 1 for finding integrating factors. So rule number 1 says that if del m del y minus del n del x by n is a function of x, then integrating factor is equal to e to the power integration fx dx. This is the integrating factor. And after multiplying by this integrating factor to the given equation, that equation will be exact. Okay. Now I will show you an example. So in this equation, we can see that this is a first order first degree ODE, and to solve, first we have to check the equation is exact or non-exact. So now since I am taking this example for applying rule 1, so obviously this is a non-exact equation, though we have to check that it is exact or non-exact, because when you will do a new sum, you do not know that the ODE is exact or non-exact. So first thing, you have to check the equation is exact or non-exact. If exact, you can solve directly. If it is non-exact, you have to use the rules for finding integrating factors. Okay. So here m equal to xy square minus e to the power 1 by x cube and n equal to minus x square y. So what is del m del y? Del m del y will be 2xy and del m del x is minus 2xy. So it is clear that del m del y is not equal to del m del x. So this equation is non-exact. Now I am using rule number 1. Del m del y minus del m del x by capital N, that is 4xy by n is minus x square y. This will be minus 4 by x, and it is clear that this is a function of x alone. So integrating factor will be e to the power integration fx, that means minus 4 by x dx, that is e to the power minus 4 log x, and this is equal to 1 by x to the power 4 by using property of logarithm. Okay. Now I will multiply the given ODE by this integrating factor. Then so multiplying, I am numbering this as 1, multiplying 1 by integrating factor. So this will be 1 by x cube y square minus 1 by x to the power 4 into e to the power 1 by x cube dx minus 1 by x square y dy equal to 0. Now this equation is an exact equation. You do not need to check that either it is exact or not. It is theoretically proved that a non-exact equation, after multiplying by integrating factor, it becomes an exact equation. For verification, you can do for one sum you can check, but it is not required for all the non-exact equation. After multiplying by integrating factor, it becomes exact or not. It is not required to check. Okay, it is theoretically proved. So now this equation is an exact equation. Now to solve this equation, we will follow the procedure of solving exact ODE I have told in the previous video. Now we will solve this equation. So here m is this and n is this. Okay. So for solving, integration m dx, integration m dx plus integration n dy, but here you can see that n is containing x, so we will not take this term. So this equal to c. Now we will integrate this. This will be minus 3 plus 1, that is minus 1 by 2x square to y square minus, so for this integration I am substituting 1 by x cube by z. So differentiating both sides, minus 3 by x to the power 4 dx equal to dz. So this will be 1 by x to the power 4 dx will be substituted by minus 1 by 3 e to the power e to the power z dz equal to c, and is equal to minus 1 by 2 x square y square. This will be plus 1 by 3 e to the power z, and z I am putting the value of z again, 1 by xs cube equal to c. So this is the general solution for our given problem. Okay, so this was an example for rule 1. Now I will discuss rule 2. So rule 2 states that if del m del y minus del n del x by m is a function of y alone, then integrating factor will be e to the power minus integration of that function dy. Okay, now I will take an example for rule 2. Just a minute. Okay, so I am taking this example: 3x square y to the power 4 plus 2xy dx plus 2x cube y cube minus x square dy equal to 0. Okay, now generally first we have to check that this equation is exact or not. Okay, though I am doing this for applying rule 2 and this is a non-exact equation, but since you will not know previously that this equation is exact or non-exact, first you have to check for the exactness of the equation. So this is m and this is n. So m equal to 3x square y to the power 4 plus 2xy, and n equal to 2x cube y cube minus x square. So del m del y will be 12x square y cube plus 2x, and del n del x will be 6x square y cube minus 2x. Now we can see that these two are not equal, so this equation is non-exact. So we have to find the integrating factor. For this example I am applying rule 2. So del m del y minus del n del x by capital M will be equal to, I am simplifying directly, 12x square y cube minus 6x square y cube will be 6x square y cube, and plus 4x by m is 3x square y to the power 4 plus 2xy. Now I am taking out 2x from the numerator, 3xy cube plus 2, and I am taking out y from the xy from the denominator. This will be 3xy cube plus 2. These are cancelled out, x is cancelled out, so the function is 2 by y, which is a function of y alone. So according to rule 2, the integrating factor will be e to the power minus 2 by y dy. Okay, if this function could not contain only y, and if this function could be a x and y, then we could not apply rule number 2. Okay, so clearly this is stated that the function should be of y alone, and in rule number 1 that function should be of x alone. Okay, so the conditions must be satisfied clearly, then we can apply these rules. So this will be e to the power minus 2 log y, and this is equal to 1 by y square by property of logarithm. So 1 by y square is the integrating factor. Now I will multiply the given ODE by the integrating factor. Okay. So after multiplying, I am writing here multiplying by integrating factor. This will be 3x square y square plus 2x by y dx plus 1 by y square. So this will be 2x cube y minus x square by y square dy equal to 0. Now this was the given problem. This was non-exact. After multiplying, the non-exact equation becomes this equation and this is exact equation since it has been multiplied by integrating factor. So this is m and this is n and it is exact. So the solution will be integration of m dx plus integration of n, but here we see that both the terms of n are containing x, so we will not take these terms for integration. So this is equal to c, where c is arbitrary constant. So after integrating, this will be x cube y square plus x square by y equal to c. So this is the general solution of the given ODE. Now we will discuss rule number 3. So rule number 3 states that if m and n are both homogeneous functions of x, y of same degree and mx plus ny not equal to 0, then 1 by mx plus ny is the integrating factor. So if m and n are both homogeneous functions of same degree, then the integrating factor will be 1 by mx plus ny. So I will take an example. Let us take this x to the power 4 plus y to the power 4 dx minus xy cube dy equal to 0. First we will have to check that this equation is exact or non-exact. Here m equal to x to the power 4 plus y to the power 4 and n equal to minus xy cube. Okay. Now del m del y will be 4y cube and del n del x is minus y cube. So these are not equal. So this equation is non-exact. Okay. Now we can see that this equation is both the functions m and n are homogeneous functions of same degree. That's how can we understand that functions are homogeneous function? If all the functions present in m and n are of same degree in total, then you can say that these functions are homogeneous. Here see that all the functions, power of all the functions are 4, 4, 4, here 3 plus 1, 4. If the powers of all the functions are same in m and n, then you can say that they are homogeneous function, and we can apply rule number 3. Okay. So since this is in this equation m and n are both homogeneous, so we will apply rule number 3 and if will be 1 by mx plus ny. 1 by mx plus ny. So we will have to calculate this. Mx means x to the power 5 plus x y to the power 4 plus ny means x y to the power 4. So this will be cancelled out and the function is 1 by x to the power 5. In rule number 3 there is no such condition that this function must be of x or y alone. Okay, so the result whatever may be the result of function of x or function of y or function of x and y both, that will be the integrating factor. Okay, there is no such condition that the functions must be of function of x alone or y alone. So here this function is a function of x alone, but this is not the condition. Okay, so integrating factor is 1 by x to the power 5. So we'll multiply this equation by 1 by x to the power 5. So multiplying by integrating factor, this will be 1 by x plus y to the power 4 by x to the power 5 dx minus y cube by x to the power 4 dy equal to 0. So already you know that this equation is now exact equation. So for solving, integration of m dx 1 by x y to the power 4 by x to the power 5 dx and plus integration of n, but n is containing here x, so we will not take n. So the general solution will be this equal to c. Now after integration, this will be log x and this will be minus y to the power 4 by 4x to the power 4 equal to c. So this is the general solution for the given ODE. So rule number 4. Rule number 4 states that if m dx plus n dy, that is the general form of first order first degree ODE, this equation can be written as y into function of xy dx plus x into function of xy dy equal to 0. If this equation can be written in this form, then integrating factor will be 1 by mx minus ny, provided mx minus ny not equal to 0. Okay, I will take an example now. Y into xy plus 2x square y square dx plus xy minus x square y square into x dy equal to 0. Now see that this ODE is in both the form m dx plus n dy equal to 0 and in this form also. Y into function of xy, this is a function of xy and this is a function of xy, x into this. Now it is not mandatory that all the ODE of this form will be given in this form in your question. Okay, so you may have to arrange the ODE, given ODE m dx plus n dy in this form for solving. Okay, so this ODE is already arranged in this form, so we can directly apply rule 4. Okay, if this is non-exact, obviously. So first we check this is exact or non-exact. If this is non-exact, then we will apply rule number 4 because this ODE is already given in this form. Okay, so m equal to here y into xy plus 2x square y square and n equal to xy minus x square y square into x. Now del m del y will be 2xy plus 6x square y square and del n del x will be 2xy minus 3x square y square. This partial differentiation procedure, how to do partial differentiation, you have already learned in previously. Okay, so I am not going to details how to differentiate partially. from the first of this chapter, first order first degree ODE, I am doing this, but I have not told you how to differentiate partially, because it is not a part of this chapter. I am only teaching you how to solve ordinary differential equation, and this is you should know this for to learn solving ODE. Okay, so you can see that del m del y and del n del x are not equal, so this equation is non-exact. So since this equation is in this form, we can apply this rule, and IF will be 1 by mx minus ny. So 1 by m into x, that is, I am doing directly x square y square 2x cube y cube minus ny. Ny will be x square y square plus x cube y cube. So x square y square is cancelled out. So this will be 1 by 3x cube y cube. So integrating factor is 1 by 3x cube y cube. Now we will multiply this non-exact ODE by integrating factor. Then it will be, this is xy square and multiplied by 1 by 3x cube y cube. This will be 1 by 3x square y plus 2 by 3x y cube will be cancelled out, dx plus 1 by 3x y square minus 1 by 3y dy equal to 0. Now this equation is an exact equation, since the equation has been the non-exact equation has been multiplied by integrating factor, and the result is this. So this must be an exact equation, exact ODE. Obviously, I am telling equation, this I should tell ordinary differential equation. Now you know the solution procedure. What we will have to do? Integration of m dx, that is 1 by 3x square y plus 2 by 3x, integration m dx plus integration of n, but here you can see that in this term x is contained, so we will not take this term, but this term is not containing any x, so we will take only this term, that is minus 1 by 3y dy equal to c. Now we will integrate this. This will be minus 1 by 3 xy plus 2 by 3 log x minus 1 by 3 log y equal to c. So this is the general solution for this ODE. Okay. Now I will discuss the last rule of this chapter, rule number 5. So rule number 5 states that if m dx plus n dy equal to 0, the general form, can be retained in the form x to the power a y to the power b my dx plus mx dy plus x to the power a dashed y to the power b dashed m dashed y dx plus n dashed x dy equal to 0. If this equation can be written in this form, then integrating factor will be x to the power h, y to the power k, where h and k will be obtained by solving the following equations, I will write those. A plus h plus 1 by m equal to b plus k plus 1 by n, and a dash plus h plus 1 by m dashed equal to b dashed plus k plus 1 by n dashed. So this rule is quite lengthy. From the equation we will get the value of a, b, m, n, a dash, b dash, m dash, n dash, and we will write these two equations. Solving these two, we will get the values of h and k, and we will get the integrating factor. Okay, we will take an example. 3y dx minus 2x dy plus x square y to the power minus 1 10 y dx minus 6x dy equal to 0. Now see, this equation is already in this form. I am telling again that it is not mandatory that the equations which for solving which equations you have to apply rule 5, that those equations will be given directly in this form. This is not mandatory. Okay, the equation can be in this form. You will have to reduce the equation in this form for applying rule 5. You do not know before solving that which rule have to be applied for solving this equation. Okay, now this equation is already given in this form, and we'll first check that this equation is exact or not. So for checking this exactness, we'll have to separate m and n, because this m and n are splitted over the equation. So m will be 3y dx, and this is with dx, so this will be plus x 10 x square. Okay, this is m, and n will be minus 2x this and this, so minus 6x cube y to the power minus 1. M and n we will find out del m del y, that will be 3, and del n del x, this will be minus 2 minus 18 x square y to the power minus 1. Clearly this equation is non-exact, so we will apply rule number 5. Okay, so for applying rule number 5, you see, if you compare this form and this equation, we can say that there is no x to the power a y to the power b with this function, so the value of a and b will be 0 0, m equal to 3, n equal to minus 2, a dash equal to 2, b dash equal to minus 1, m dash equal to 10, and n dash equal to minus 6. Now I am removing this. So now I will write the values of a, b, m, n, a dash, b dash, m dash, n dash. So a equal to 0, b equal to 0, m equal to 3, n equal to minus 2, and a dash equal to 2, this 2, b dash equal to minus 1, this minus 1, m dash equal to 10, and n dash equal to minus 6. Okay, now we will write these two equations. By solving these equations, we will get the values of h and k. So if we write these equations, it will be like a, will put the value of a, b, m, n. A is 0 plus h plus 1 by 3 equal to 0 plus k plus 1 by minus 2. And the second equation will be 2 plus h plus 1 by m dash, that is 10, equal to minus 1 plus k plus 1 by minus 6. Okay. Now we will have to solve these two equations. Before that, I am simplifying these equations. This will be minus 2h minus 3k equal to 3 plus 2 5, and this will be minus 6h and minus 10k equal to 10, this will be cancelled out, so minus 18, this will be plus 18, and we can write this as 3h. If we taking out minus 2 from all the terms, that will be 3h plus 5k equal to minus 9. Okay. Now for solving these two equations, we will use elimination method. So multiplying this equation by 3, this will be minus 6h minus 9k equal to 15, and I am multiplying this equation by minus 2, this will be minus 6h minus 10k equal to 18. So I am subtracting plus minus, this will be cancelled out, and this will be k equal to minus 3. Okay. Now if we put the value of k in this equation, then this will be 3h minus 15 equal to minus 9, 3h equal to 6, h equal to 2. So we got the values of h and k, h equal to 2 and k equal to minus 3. So the integrating factor will be, according to rule 5, x to the power h y to the power k, that is x to the power 2 y to the power minus 3. So this is the integrating factor. Okay. Now we will multiply the given equation by this integrating factor. So I am removing this. So after multiplying the given equation by x square y to the power minus 3, this will be 3y into x square y to the power minus 3, that is 3x square y to the power minus 2 dx minus 2x dy multiplied by this, that is 2x cube y to the power minus 3 dy plus 10 x to the power 4 x to the power 4 y to the power minus 3 dx minus 6 x cube, sorry, this will be x to the power 5 and y to the power minus 4 equal to 0, dy equal to 0. So after multiplying, this is the equation. You will have to, when you will practice this sum, you will have to multiply, then you can understand this, how this comes. Okay. Now I am separating m and n, otherwise we can't solve this equation. M is 3x square y to the power minus 2. M is the terms which are with dx, this and this. So plus 10x to the power 4 y to the power minus 3. This is m, and n is, I am taking out minus common, 2x cube y to the power minus 3 plus 6x to the power 5 y to the power minus 4 dy equal to 0. So this is m and this is n. Now this is an exact equation, you know. So for solving, integration of m dx, 3x square y to the power minus 2 plus 10x to the power 4 y to the power minus 3 dx, and in n both the terms contains x, so we will not take the terms of n. This is equal to c. Okay. So after integrating, x cube y to the power minus 2 plus 2x to the power 5 y to the power minus 3 equal to c. Okay. So this is the general solution of the given ODE. So all the rules for finding integrating factors have been completed. Okay. So you have to practice sums for all the rules. When the sum will be given in the exercise, it will not be clarified or it will not be stated that this sum will have to solve by applying rule 1 or rule 2 or rule 3 or rule 4 or rule 5. First you have to check the equation is exact or not. If this is non-exact, then you have to find out which rule have to be applied for solving this sum. Okay, so much you practice, as more you practice, you can find out quickly that which rule have to be applied for the corresponding sum. Okay, so when you practice sums, this type of sums, if you face any kind of problem, you can contact with me. My contact details is given in the first of this video. Thank you.